Hey peoples, this is what you would have missed, so I'm going to try and go through it really quick. This would have been our question of the day, and you actually already have the handout. Hey peoples, this is what you would have missed, so I'm going to try and go through it really quick. This would have been our question of the day, and you actually already have the handout. We are asked to label things we've done before, like energy, force, position, velocity, acceleration, all those things. So when you see these scenarios, you are immediately supposed to know that when you're at amplitude, that you have your maximum spring energy here, and your kinetic energy is 0. And when you're at equilibrium, your kinetic energy is a max, and your spring energy is 0. Okay. You should just know that. And again, here, your spring is max and your kinetic is 0. Sorry, the stylus is not working very well. All right, but let's get into labeling some other things. We've done all of this before, so this might go a little quick. Here, x is a positive max. Here, x equals 0. Here, x is a negative max. Here, x equals 0, and here, x is a positive maximum. We can plot those points, actually. We get positive, 0, negative, 0, positive, and so on. And we can graph that puppy. That's the best I can do on a screen. Okay. What else are we asked to label? We're asked to label velocity. Let's do some velocity labeling. That sounds like exciting stuff. So at amplitude, at our start here, you're supposed to know that V is 0 because it's not moving. At amplitude, you're not moving, but at equilibrium, it's a maximum. And in this particular picture, we are moving to the left, so it's going to be a negative max. Here we have velocity of 0. Here we have a positive maximum. And again, at amplitude, it is 0. So you're just supposed to know at equilibrium, it's all about kinetic energy. It's all about kinetic energy. You're moving the fastest and you have the most kinetic energy. So if we plot those points for velocity time, it looks something like this. So we went from a cosine curve to a negative sine curve. We are also supposed to be labeling force. Well, force of the spring is negative kx. You're supposed to know that when x is 0, like at equilibrium, your force must also be 0. So at equilibrium, your force is 0. But at the ends, you have the maximum displacement. So Hooke's law, which is F equals negative kx, when x is a maximum, force is a maximum. In this particular case, for the start here, we have a negative max because it is pulling back to the left. That's number 1. And number 2, if you use Hooke's law, when you have a positive x, you have a negative f. Similar here, your force is, the spring is most compressed. It's going to be pushing back to the right the most. And then again here, your force is going to be a negative maximum. For the picture in the middle, you have a negative maximum displacement. Negative times negative gives you a positive force. I don't know why I'm not allowed to erase. Let's plot those points. Oh, I got to scroll down. Let's plot those points. We got negative. What did we start with? We started with negative. Sorry. That took me a long time to figure out. While you listen to me figure that out. My stylus is being a pain. And I can plot that nonsense. Also, this should be really easy. F equals ma. So that means that the force and the acceleration are in the same direction. So A would be it's not letting me write, negative maximum here. Sorry, it's not very neat. A would be 0 in the middle. Here, A is a positive max. A equals 0, and here A equals negative max. They're literally the same graph because F equals ma. Did I do that right? Probably not. I did not. Sorry about that, peoples. I'm trying to rush. So you get the same exact graph. Okay. I've already kind of like done this so you can see what it better looks like here. I'll come back to this, and of course you can pause the video anytime you want. But what you're really supposed to take away from with this graph is when you're at equilibrium, it's all about velocity. You're moving the fastest. Kinetic energy is the greatest. Everything else is zero. You're just supposed to realize that and understand it. But when you're at amplitude, you come to a stop. So your kinetic goes to zero, but everything else is a maximum. Spring energy, force, acceleration, all those things. So this was the notes from the board. They look a lot neater than what I just tried to do. A couple things about this. It's been a long time, but to go from a position time to velocity time, we look at slope. And the slope in the beginning here is 0, then it's negative, then it's 0, then it's positive. And if you look, your velocity goes from 0 to negative, 0 to positive. So you could look at slope. Okay. Another like slightly dirty trick that you can do is for the next graph, if I cut this off at a quarter and slide it over, I get the velocity time graph. If I cut this off at a quarter period and slide it over, I get the acceleration time graph. It's pretty interesting. Okay, but here's the deal. Some things to know. If the force of the spring equals ma, that means F and A will be the same graph. However, since the force of the spring is negative kx, x and A must be opposite each other. Same thing with F and A. They must be opposite each other because of the negative symbol. So if you look at the position time graph and you look at the acceleration and force time graphs, they're literally mirror images of each other because they're opposites. Also, AP has graced us with this equation here and this one here. These are to find the position based on amplitude at some time later. So it says x, your position, is equal to your amplitude times the cosine of 2 pi frequency times time. Your velocity is based on the negative velocity maximum times sine of 2 pi frequency times time. I spent a lot of time trying to figure out what are they going to do with these expressions because I thought we would have to go into more detail. Not so much. Woo, hello. Here's an example. And this is in your homework, actually. So it's just really quick. This is not a major player for us when it comes to our test or even the exam, the AP exam. I've really not seen much to do with this. But here's a scenario where we release something from x equals x max. So that's basically your amplitude. And the period is t. And we're trying to figure out, hey, where is it when time is 1/8 of the period? Okay, this is not a big one. X equals a cosine of 2 pi frequency times time. Well, first of all, they give us time. It's not, let me write. Time is t over 8. But frequency and period are inverses of each other. So actually, t equals 1/8 frequency. I just changed period to 1 over frequency. So I can sub that puppy in. So I get x equals amplitude, we were told, is positive x max cosine of 2 pi frequency times the time, which we said was 1/8 frequency. Okay, frequency go bye-bye, 2, 4, and we end up with x is going to equal x max, come on, it's not letting me write for some reason, x max cosine of pi over 4. That's it. Like, I don't know what else we're asked to do with this. This was a multiple choice. All right. So that was the question of the day that you would have missed. Sorry, that took a long time. It's like 9 minutes. Wow. This is the homework that we would have gone over. Reminder that you will be asked on your test, which is still on Friday, you're going to have parallel springs. Just remember you have to add them together. Okay. So for this one, these were in series. So we got the total spring constant of K. These on the right were in parallel. So we got the total spring constant of 3K, and then K and 3K are in parallel together. So you get 4K, and then basically you do the rest of the questions. And that's about it. I don't remember what number 2 was. Why don't I know that? I don't know, but apparently it was springs in series. Then there must have been a collision, and then we must have used that to find the period. And then we use that to find the final velocity. All right, speaking of homework. This is the homework that is due Thursday. It's graphing homework. It's really not a big deal. I would like to tell you that you are not drawing graphs on your test. However, if you can draw a graph, you can clearly identify what's going on for a multiple choice. But here, we're given a position time graph, and you should immediately see that the period is 0.8 seconds. Wow. I also see that the amplitude is 0.25 meters. With that information, you should be able to answer all these questions, like what is the spring constant? Well, if I know the period and the mass, I can get the spring constant. It says half maximum amplitude. What is the acceleration? Well, half of 0.25 is 0.125. So what is the acceleration when the displacement is 0.125 meters? Also, you should be able to see this position time graph and immediately say things like, okay, right here at half the period, we are at equilibrium. X equals 0. At equilibrium, that means kinetic energy is the greatest, velocity is the greatest, and clearly we are moving in the negative direction. We have a negative slope. At the same time, if I see this negative position maximum over here, I should know that that is amplitude. At amplitude, kinetic energy and velocity are 0, but my amplitude is most negative. My spring energy is a maximum. The force is pushing it back to the right, and my acceleration will also be to the right, just by looking at these graphs. You're also asked to graph potential and spring, as well as F and A, and on these graphs, and velocity as well. Again, another graph. I can look at this graph and see the period is 2 seconds. The maximum speed is 1.25 meters per second. With that information, I should be able to answer all the other questions. And these last two down here were based on the multiple choice I could find. So that's basically it. This homework is sadly due Thursday, even though we won't see each other Wednesday, and the test is still Friday. I can promise you that if these two questions here, the graphing questions 1 and 4, you'll see something exactly like that on your test. But also, if you look at the review, these two questions, numbers, well, the ones between 5 and 8, these questions are on your test. So you can be guaranteed that your test will have a position time graph, you'll be asked questions, a velocity time graph, and you'll be asked questions. These are not too difficult. You just look and you can immediately get the period as 1.5 seconds, and the max velocity looks to be about 1.5 here. What can you do with that information? Apparently for this graph, you're gonna have to fill stuff in. So anyway, that's it with graphing. The homework is due Thursday. Our test is still Friday.